The image you see here is of the largest hydroelectric dam in the world. It's in China and it's called Three Gorges Dam. A hydroelectric dam converts energy from moving water into usable forms of energy that our households need. The water is dropped from a height and then it spins a magnet, which converts the energy from the movement of water into electricity. When the water is at a height above ground, before falling, it has potential energy. Do you think that something higher up or closer to the ground has more potential energy?
So gravitational potential energy is calculated by multiplying mass times g, which is acceleration due to gravity, times height. So if height increases, according to this equation, gravitational potential energy also increases. So if you're higher up, you have more gravitational potential energy. So GPE stands for gravitational potential energy, M stands for mass, and G stands for acceleration due to gravity. And on Earth, the acceleration due to gravity is always 9.8 meters per second squared. And then H stands for height. You multiply M times G times H, and that will give you the gravitational potential energy for an object. Okay, units for GPE, gravitational potential energy, are joules. Units for mass are kilograms. And units for G, the acceleration due to gravity, are meters per second squared. Units for H, height, are meters. So again, here's this little table, and we're going to go over the letter in the equation, what it means, and the units that it's measured in. So if the letter in the equation is GPE, gravitational potential energy, it's measured in joules. The letter M in the equation means mass, and it's measured in kilograms. The letter G in the equation is acceleration due to gravity, and on Earth it's always 9.8, and it's measured in meters per second squared. And then H, the letter H in the equation means height, and it's measured in meters. So when you're using this equation, when you're using the equation GPE equals M times G times H, if you see the value 300 joules, does it go in for GPE? Does it go in for M? Or does it go in for H in the equation? The hint here is that it's measured in joules. We said joules was a unit of energy, so 300 joules is gravitational potential energy. That's where it would go in the equation. How about 300 kilograms? If I see that, where would it go in the equation? Which letter does it stand for? The hint here is that it's in kilograms. Kilograms is a unit of mass, so you're going to know that 300 kilograms equals M. Then, finally, if I see the value 300 M, does it go in for gravitational potential energy, mass, or height? 300 M stands for 300 meters. Now, people could get tripped up here because there's an M here, and there's also an M here. What's the difference? The M here is the unit that it's measured in, that the 300 is measured in, meters. The M up here is just a placeholder for a number. The M up here stands for mass, and once you have mass, you're going to put it in here. Since this M stands for height, this 300 M goes in for H, not for M. So don't let the M down here and the M up here confuse you. If you see it coming to the right of a number, then it's the unit. If you see it in the equation, then it's mass. Okay, what number always goes in for G on Earth? That's 9.8. You want to be more precise, it's 9.81, but for our purposes, go ahead and just use 9.8. Okay, our last example. We're going to do an example of calculating gravitational potential energy. So the example says a 2-kilogram watermelon is falling from a height of 10 meters. Calculate its potential energy. Step 1, define the variables. So the first number that comes up in the problem is 2 kilograms. It's measured in kilograms, which is the unit of mass. So we're going to say M equals 2 kilograms. Next number that comes up, 10 meters. Since it's measured in meters, we know it's a unit of height. So we're going to say h equals 10 meters. Again, don't confuse this m and this m. This m is mass. It's the letter in the equation. This m is meters. If it comes to the right of a number, you can always assume that it's meters. And then g is not given to you in the problem, but you're on Earth, and g on Earth is always 9.8. And finally, the problem asks you to find potential energy. So we're going to say GPE, gravitational potential energy, is question mark. Step 2, write out the equation. This equation is different. Don't try to use the kinetic energy equation when you're calculating potential energy. So if the problem asks you for potential energy, you want to use the equation GPE equals m times g times h. Step 3, you want to plug in your numbers and solve. So m was 2, g was 9.8, and h was 10. So GPE equals 2 times 9.8 times 10, which would give you 196 joules. Okay, guys, that is it for today. If you have any questions, contact me. If you'd like more examples worked out, come to our optional video conference. I'm so proud of you. Keep up the good work. You're doing great. Yay.